Hi guys, today's lesson we're going to be learning about sound. You're going to need something to write with, something to write on, and your attention span. When you're using this lesson, make sure you're pausing and having a go at all of the questions and then playing it to see the answers. When you're having a go at the independent practice, rewind and rewatch the explanation section as much or as little as you need to. Let's get going. So I want you to try something for me now. I want you to just knock on the table you're sat on and get used to the sound that it's making. And then put your ear right on the desk or the object you're knocking, so your ear's flat on it, and do the same sound. Now hopefully you notice it sounds slightly different to what you did before, or what it did just through the air. And now this is because of how sound travels. So if we have our source of the sound, so this can be our source, all right, the knocking. Now, the source of a sound is a vibration, a movement backwards and forwards. And that vibration is going to cause the particles around it to bump into each other, collide and bundle up. Particles around it are still spread out, but once they've bunched up, that sound travels and moves. So this is it a little bit later, and so on. So that sound wave is moving across to eventually where it ends up in your ear. And that's the best picture of an ear I can do. Now in the air, our particles are really spread out, so it sounds in one kind of way, but in a solid, particles are packed much closer together, right next to each other. So they're going to transfer that wave much quicker because they can bump into each other much quicker. All right, so that's what's going on there. Now, inside the ear, we have the eardrum. I can't draw a very good eardrum, I'm afraid. The eardrum is a solid, and that picks up the sound because it is in turn caused to vibrate by these particles bumping into it. So the conversion of that sound wave into the sensation that we hear in our heads is that vibration of the eardrum because of the particles colliding with it. Okay. Sound, as you can see, these particles are oscillating in the same direction that the wave goes, so therefore it is longitudinal. Okay, the areas of particles that are spread out, these are called rarefaction, and the parts that are compressed together are our areas of compression. Okay? And the last thing to state is just different animals, okay, will have different shapes and sizes of eardrums. So they'll pick up different ranges of frequencies because of how the eardrum is shaped. Humans can hear from a range of about 20 hertz to 20,000 hertz because of the shape and size of our eardrums. Different animals have different hearing ranges. Like bats, for example, can hear much higher frequency than us because they have that different shape of eardrum. Okay, here are your key points to embed, guys. Make sure you've got these written down. All right, have a go at embedding those points. Self-test yourself. Use a whiteboard if you've got one. Use a piece of paper. Look through it, say it in your head, cover, say it through in your head again, write and check your answer. Or if you've got someone else there, get them to quiz you. All right, guys, here are independent practice questions. Have a go at these. Do the best you can. If you need to, go back and rewatch the explanation or use the notes you've taken from the video. Here are your answers. Well done if you managed to get all of these. And the last few, we can fit all into one diagram there. Well done if you managed to get all of those. You guys are working really well. I'm really impressed. That's all for today, and I'll see you next time.